Hello everyone, hope you're having a great day and I welcome you all to this day 12 of AWS series. Today's session is all about auto scaling in AWS. This session is going to cover different scaling methods work on AWS. So without any further ado, let's start the session.
Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
Let's see first what are the types of autoscaling in the market. Suppose you have a M3 dot medium instance size and you have a EBS, that's a root volume of 40 GB size to that. Now if you want to increase the capacity because your load is increasing, one way is from M3 dot medium you change the size to M3 dot large. To change the size you have to stop the instance and then change the size, provided this is an EBS back instance. Yes, if you want to change the size from 40 GB to 80 GB, you can also do that. You take a snapshot, you create a new volume of 80 GB, attach as a root volume. But changing the instance size or changing the volume size, in these two cases, it would require instance to be stopped temporarily and then the size would be changed. But that is possible. If you can do it in a off peak hours or something, you can back up. It's a possible thing. In another case, you want to change size from M3 dot medium to M3 dot extra large again by stopping server. Yeah, if you don't want to remove the original size of the EBS volume, you can attach additional EBS volumes also. You can rate them and then you can make them as a one EBS volume. All these cases are case for the vertical scaling. In the vertical scaling, you add resource vertically to the your current infrastructure. Whether you add memory, you add compute power, whether you add storage, all the cases are of the vertical scaling. Vertical scaling has some kind of a limitation because one limitation we just saw, it may require the instance to be brought down. In some cases, there is a threshold. Beyond that, if you keep on adding more resources, it may not improve the performance because eventually it's a single machine. A single machine has its own limitations, which might not work beyond certain capacity. So when you think about M3 dot extra large, M3 dot large, in both the cases, this is how it's going to work. Let's think over the other another option that is known as a horizontal scaling. The horizontal scaling case, you add more resources horizontally to your fleet. So you have one M3 dot medium, you add one another M3 dot medium, you add another M3 dot medium. All three are managed by the elastic load balancer. So suppose you have a 10 requests coming up. Now even if you have a 300 requests coming, it would be evenly distributed among each machine with the 100 requests. So that's the horizontal scaling for you. Amazon Autoscaling helps you achieve horizontal scaling. It adds more resources horizontal to your plate, and you can also make them part of the ELB automatically, which allows you to scale horizontally. And believe me, the horizontal is the go-to thing for you because if you want to add more and more from 5 to 10 to 15 resources, that's a possible. Plus, it does not need any downtime and it doesn't need or it won't have any capacity threshold like a vertical scaling. You keep on adding, it would work perfectly for you. Auto scaling helps you achieve horizontal scalability for your applications. It's a perfect case for the high availability. It can scale up and scale down EC2 capacity automatically based on the conditions defined. You can manage your desired capacity. Now, what is that? When you make an auto scaling case, it would have three kind of a parameters: minimum size required, maximum size required, and desired capacity. Minimum means it would never go below those many numbers. So suppose at any moment you think I need two EC2 instance running. So at auto scaling level you define that I need two as a minimum. Now due to any conditions it would keep adding more resources because there is a load increase something. What happens if there is a DDoS attack and it keeps adding more and more resource? You don't want to do that. Or there is a known case because you know there is a virus scan going on. It's not a real increase in the load, but my CPU is behaving oddly. What you can do is you can set up the maximum limit also. You can say my maximum limit is 8. So when the load increases, it keeps adding more and more resources. So from 2 to 3 to 4 to 5, it would not go beyond 8. It would stop at 8. So this way you can control. And at any moment, how many instances you want, that is defined by the desired capacity. You would see in the demo how can you scale up, scale down, how can you define the minimum size, maximum size, and the desired capacity. But it's important to understand these are the three parameters: minimum size, maximum size, and the desired capacity. And with this, you can see you can increase or decrease capacity seamlessly. Now that's why this is the perfect case of the cost optimization. You would say, how would it optimize my cost? Imagine if you have 5 instances. Now, for these 5 instances, you might have to, you don't want the 5 instances running all the time. You say at any time keep two running. Whenever required, load increase, add one, two, three more instances over there. If you were in your own data center, you might have a procured capacity as per 5 instances and it would running. Here, you are running only 2 instances. As and when load increases, you add more resources. As and when load decreases, you remove the resources. And beauty of Amazon is you pay for only what you have used. So you would be paying for those 2 3 instances only when they are available or only when they are being used. That case, you would be paying for those additional 2 to 3 instances for some few hours only. That's why it's a huge cost optimization for you too. Autoscaling helps you to achieve the best of the high availability because it does keep check of the health of the instance, and even if it finds any of the instance unhealthy, it would terminate that and launch a new instance for you. You will read a little bit more about that in the future. Also, if you think, it helps you since it's a scalability. So if one zone goes down, so that instance stops behaving, it would automatically scale up because the CPU load increase, something like that, and it would help you achieve high availability and disaster recovery too. Autoscaling is ideal for hourly, daily, weekly variability. If you have a load, something which is in a spike, something like this, that's not the case. The reason is by the time it spikes up, you are about to spin up a new instance. It has spiked down, it has come down, and it's about to be terminated. Then again it spiked up, it is about to be launched. So you have to find a pattern and baseline something, and then only you should be setting up the auto scaling formulas or events to come across. It works with the ELB and the CloudWatch perfectly. We'll be seeing in the demo how does it help you. And the most important, it does not cost you extra. It's a free of the cost service. So auto scaling is elastic by nature. We know it's elastic. It can add more compute power elastically, and that's why it helps you in the dynamic scaling. You want to add the resource, you want to remove the resource, it helps you for that. And that results in your cost savings because you are paying for the resources which are added only when required. So helps you for high availability. The important point is it works within a region only. So auto scaling is particular to a region. So whatever condition defined would be part of that region only. Whenever load increase, it would keep on adding. Whenever load decrease, it would keep decreasing. It works in that way. Autoscaling, how do you work with that? So there are the few steps you need to follow when you are working with autoscaling. First and foremost step is you create a launch configuration. So when you go to the autoscaling, there are two things you need to work. One is a autoscaling launch configuration, another is a autoscaling group. Now what is a launch configuration? You have to think what is the role of a autoscaling. It launches an EC2 instance based on the condition. Now, while launching an EC2 instance, what all parameters do you need? You need instance size, you need key pair, you need AMI because it would be launched from that, you need security group, you need EBS volume, and a few parameters which are required to launch an EC2 instance. While launching an EC2 instance, we have followed these steps multiple times. That is the exactly thing you define in a launch configuration. Here you identify the EC2 runtime parameters. That's a very important. The AMI ID is the most important because you want that I have a application set up with the Apache web server. Now I want to do that the whenever there is a load increase, it would add a Apache server over there or new instance over there, which is the Apache server already running part of that. What you can do is you set up an EC2 instance, install Apache over there, configure that the whenever the instance boots up, Apache starts automatically, and create an AMI out of that. Provide that AMI to EC2 launch configuration. So in future, whenever autoscaling launches a new instance, it would launch this also. It would also launch this instance, and where the Apache is already installed, Apache would start automatically, and you make it part of the load balance, it would start running for you as it is. It's very important you identify the runtime parameters, and that would be defined based on your AMI. That's the one key aspect. Apart from the AMI, you would be selecting more parameters like key pairs and the security group and the EBS volume size and a few more. The next step is, and here you are just identifying parameters. The next step is you create an auto scaling group. In the auto scaling group, you would be selecting or taking this launch configuration as part of this, as well as you define maximum size, minimum size, and desired capacity as part of this. You also define which all zones does this. I'm talking about zones of a region, not multiple regions. Zone of a region, which all zone this auto scaling be part of. So what happens? As soon as you create an auto scaling group, it would launch an EC2 instance. How many instances it would launch? It would be based on the desired capacity. And if you have not specified desired capacity, then what is the minimum capacity you have specified? Based on that, it would launch EC2 instances. Those instances would be launched based on the launch configuration parameters you have selected. It would select the same AMI ID, same key pair, and everything it would take out of that. So your first step was creating a launch configuration. Second step is just creating an auto scaling group. Once all this is done, you can create an auto scaling policy. In the policy, you define that whenever there is a threshold above 60%, below 60%, something, or based on time, you launch a new instance. So as soon as CloudWatch detects the condition breach, it would notify auto scaling and it would execute this scaling process. When the scaling process is executed, that also be part of ELB. You have configured that. So everything works seamless for you. Launching a new instance, and even if the vendor it goes below the threshold, it would terminate the instance also. So when you think of the auto scaling process, the important steps are creating a launch configuration, creating an auto scaling group, and creating a policy for that. Auto scaling with the elastic load balancer gives you a perfect resiliency. So what happens? Suppose auto scaling has launched an EC2 instance. Now that instance is also added to the elastic load balancer. Autoscaling itself also performs the health check on the instance. Now we know ELB does perform the health check on the instance. Autoscaling also performs the health check on the instance. In this case, as soon as the instance becomes unhealthy, ELB would stop sending traffic to that instance. ELB would stop sending traffic to that instance. We know that ELB keeps check of the health of the instance. When it's unhealthy, it stops sending traffic. And if it's unhealthy, autoscaling would terminate that instance automatically. And since it's a terminated, so your desired capacity has to be maintained. Autoscaling would launch a new instance as per the desired capacity. That instance would be part of the ELB again, and the whole thing starts working back to the normal. So even if due to any zone outage or any other outage Amazon level instance goes down, ELB would stop sending traffic to that. Autoscaling would terminate and launch a new instance for you. That would give you the case of the perfect resiliency. Autoscaling works in the three scenarios. Let's see what are the possible cases in this three scenario for the autoscaling. First is a based on the time. Scaling based on the time. You can create a schedule action. Suppose when you are doing your load monitoring with the CloudWatch, you feel at every day 9 a.m. the load increases and every day 5 p.m. the load decreases. What you can do is autoscaling allows you to scale based on the schedule. So you can create a schedule where based on that load it would automatically increase the capacity, based on the schedule it would decrease the capacity also. You can set up the time in Amazon Management Console. You can also set up, it's not a week, one day. You can set up that if it's a recurring, it's a one time, what do you want to set up that? And based on this desired capacity, it would be changing that. So this is scaling based on time. Where you know the pattern and you want to scale up, scale down, you can do that. Second is a dynamic scaling, where you want to scale based on the conditions. You don't know your application is working normally, but suddenly there is a huge hike on the load. Let's at the 9 a.m. the load has decreased, increased by the 50% or 60%. At 5 p.m. the load has decreased by this something. It happens. Now, what would you do that? You would be creating a policy for scaling up and scaling down. You can say that, sorry, it's not a time waste, that's my miss. You can set up that, okay, when there is a CPU utilization. So if I say my application is working normally, my normal CPU utilization should be below 60%. Now, due to certain conditions, if the load is increases and it stays there for a longer period, you can set up a policy which would scale up automatically based on these conditions. So you can create a CloudWatch alarm which says that whenever CPU is more than 60%, notify auto scaling. Now, this auto scaling would then take up and launch a new instance as soon as it receives a notification from the CloudWatch. You can also set up a bottom threshold that whenever it's below 20%, again notify auto scaling. So whenever it goes below 20%, it would then also terminate the instance. So you can set up the scale up policy and scale down policy. In the same game, third is the manual scaling or the constantly growing scaling. When you want to follow the certain pattern, how you want to scale up or scale down, you can do that. And this is more about, you know that okay, this is the time I want to increase the load. You don't want to wait for any conditions, you don't want to wait for any time base, you want to do it manually. This is the case for you. It's very easy. You just go to the CloudWatch, you just go to the auto scaling and change the desired capacity to your required, and it would be based on the desired capacity, it will scale up or scale down. The one of the exact example I would say, due to certain conditions you have set up that okay, it should scale up, but you don't want to set up the scale down policy as of now.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So what you've done is, when the load increase something happens, you would be scaling up. Now after some time you think okay, this is the time now I want to scale down, you can go and manually change the policy. Again, as long as there is a less manual intervention, that is the best policy, but in some cases you might require that. So you can think of that option too. This is a simple architecture of the how the auto scaling things would work. You would have a website, something like example.com, that is being mapped to some IP address of the load ELB, and I would say not IP, it's a DNS, using Route 53 service. With this elastic load balancer would be sending the request to the instances, and there is an auto scaling configured as part of that. When auto scaling is configured part of that, and whenever there is a threshold or some breach of the conditions, it would add more resources to this auto scaling group, and that would be again part of the load balancer. So when the load increase over the example.com, automatically it would be taken care by the using elastic load balancer, auto scaling group, and CloudWatch. It can scale up, scale down based on the policy defined, and it receives the alarm from the CloudWatch. Let's try to understand a few vocabulary of the autoscaling. Autoscaling has a launch configuration. The launch configuration we spoke about, it's a first step to create your autoscaling where you define what all runtime parameters it should use to launch an instance. This is the EC2 runtime parameters. Then it does have an autoscaling group too. Autoscaling group is nothing but a representation of a multiple EC2 instance. So it uses the launch configuration to launch an instance, but what would be the max size, minimum size, what zone it supports, that all thing you define in the autoscaling group. As soon as the group is created, it launches a new instance. You also have a policy. A policy is that you define that based on the response from the CloudWatch, what action should autoscaling take, whether it should scale up or scale down, that is defined in the policy. A trigger is nothing but the what you receive from the CloudWatch. When a CloudWatch receives you receive an alarm from there, it would be part of that. It is part of a CloudWatch alarm and autoscaling policy. So as soon as the alarm crosses the threshold, it notifies autoscaling. Autoscaling policy would be executing the thing. That's the whole thing is called as a trigger. And autoscaling keeps checking the health of the instance regularly. It does perform the health check and keep the check of the status of the health. So as soon as it finds any instance unhealthy, it would terminate that and launches a new instance on place of that. What are the use case for the autoscaling? It's ideal for the web tiers or stateless tiers. So you should use it for the Apache, Nginx, Tomcat, JBoss, wherever you have a web service tiers, it is required for that. Can you use it for the load database? You cannot. We'll see in a moment. So ideally, when you have web servers which are facing the external web traffic, or when you have a stateless tiers which does not manage your states, that is the case for the auto scaling. We learned the three types of the scaling: manual scaling, scaling by schedule, and scaling by the policy. It's a recommended that you should have a two policies, one for scaling up and one for scaling down. Let's try to see a little bit of the scaling in depth. The scaling is recommended when you have a gradual rise or the gradual low. If you have a spiky requirement, scaling is not for that. Yeah, there's a spike of the increase, scaling is that. But what I meant is spike up, down, up, down, up, down. That is not the case for the scaling. You can create up to maximum 100 launch configuration as part of the auto scaling. In some case, you want to suspend the scaling, you want to resume because you are doing something new installation, you are doing something over the instance, you know that. So you can suspend or resume the scaling also. You can have maximum 125 schedules actions for auto scaling group. So every day it can have allowed 4 actions per day. That's a possible. Also, when auto scaling is terminate the instance, you can define in which way it should terminate. That is the oldest instance first, newest instance first, instance with the oldest launch configuration first, or instance which is closest to instance R, that is for the pricing base first. You can define that also, and we would see that also in our demo. We know that EBS back AMI boots faster than the instant store back. Ideally, word should be instant store back AMI.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 is which type of storage service? A. Object. B. Simple. C. Secure. D. Block. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And even it's easily to make also. So that's a recommended to use the EBS back AMI as much as possible. Yeah, you cannot modify your existing launch configuration. So in case you have created a new AMI and you want to change the launch configuration, what you have to do is create a new launch configuration and modify the auto scaling group with this new launch configuration. You cannot update existing launch configuration. You can use spot and reserved instance also with the auto scaling. Auto scaling works across the multiple availability zones within a region only. It works seamlessly with or without ELB. In some cases, you might not need ELB because you're doing some Hadoop or batch processing. You can use the auto scaling for that purpose also. Auto scaling checks the health of the EC2 instance regularly. It does perform the health check and During the health check, if find the status of the instance okay, then it's a good. Also perform the health check of the ELB also. If it find the ELB health check in service, then it's a good. If it find it's not running, because what happens, an EC2 instance is registered with the ELB. Now, when it's registered, the status of the EC2 with the ELB would be in service. Due to any reason, if it's out of service, autoscaling would mark that instance unhealthy and terminate that. If an ELB is unhealthy, all instance will be also marked as a unhealthy. Autoscaling does also support its own metrics for the CloudWatch. They are like what is the minimum size, maximum size, desired capacity. Yes, if you have enabled the detailed monitoring with the autoscaling for EC2 instance, that is a chart. Autoscaling should never be used with the database unless it's a read-only data. Why? Imagine a case, you have a database. Now, suppose the load rises and you say, I want to spin up new database instance. What would that result? It would result in inconsistency because some data comes to this machine, some data comes to this database. The data is not consistent. You cannot have a two instance. So, and plus autoscaling can terminate this also whenever this load decreases. So your data would be lost. Since it's a persistence tier, autoscaling should never be used with the database. If you have a read-only database, then only you can do that. So what happens that your data is coming only for the reading part. It's not doing any insert, dealing, anything update part over there. Then it's okay because if you have a 3 instance, 5 instance, even if the one terminated, you don't mind because it's a read-only thing. When we go to the RDS, we will see that read-only part too. If you have a critical configuration like log, audit trail, something coming to the EC2 regularly, you should plan keep moving them to the S3 at regular interval. You should also optimize your resources after monitoring pattern. You should keep monitoring your resources regularly, and whenever you find upward, downward scale, you should add or remove the resources too. So this is all about the auto scaling in the theory.
So guys, elastic load balancer basically is a technology unit which can help you distribute traffic among multiple EC2 instances. Okay, why would you want to do that? Because obviously when you are dealing with production architectures, there can be no one server which can basically cater to all the traffic which is coming in. For example, on Google, there are around 2 billion searches which happen every minute. Now, these many of searches have to be processed, and obviously there is no one server which can process this much amount of data. And that's why what Google does is it basically makes use of multiple or thousands of servers to cater to this kind of a traffic, right? But how does basically Google.com process our information from one domain, that is Google.com, to multiple thousand servers? So how does Google know which server will process which information? How does Google know that if you are searching on Google.com, which server will you be allocated on? So that is something that is a concept of load balancing, and that is something that we are also going to discuss today. Not probably on the scale of Google.com, but probably in the scale which we can understand, that me and you, we both can understand as people who are trying to understand load balancers. Okay, so let's start off by understanding what is a classic load balancer. All right, so a classic load balancer, guys, is a load balancer which distributes traffic equally among the EC2 instances which are below it. Okay, so let's say I have 5 EC2 instances which I have deployed. So what my classic load balancer will do is it will distribute the traffic equally among all the 5 instances which are there. There are no conditions which this elastic load balancer understands. It only understands that if X amount of traffic is coming to me, and if I have 5 servers, I have to divide the traffic equally, that is X by 5 traffic on each and every server which is under me. This is what a classic load balancer is. Why is it called classic? Because this was the old way of dealing with load balancers. But now that we have moved forward, we basically are going to discuss a new type of load balancer today, which is called the application load balancer. Now, application load balancer also distributes traffic, but it is an intelligent load balancer. And what it does is it basically operates on the 7th layer of the OSI model. Now, if you do not understand what the OSI model is, it's just fine. In simple terms, what I can tell you is this load balancer, you can basically configure based on conditions. So you can tell this load balancer that if this condition is true, then route the traffic to this particular EC2 instance. If the traffic, if this condition is true, or if the second condition is true, route the traffic to some other EC2 instance. So this is an intelligent load balancer which can work on conditions. So what conditions can it work on? It can basically work on the condition of paths. Now, what is a path? A path is basically what you type in the address bar of your browser, right? So for example, if you type in google.com/Gmail, you will reach the Gmail page. So let me just try to show you. So if I type in google.com/Gmail, let's see what happens. So in this case, my Gmail will open, right? My Gmail has started to open. If let's say I try to open google.com/Google Drive, let's assume, let's type in Drive. Let's see what happens in that case. So when I type in google.com/Drive, I am basically reaching the Google Drive page. Now you will imagine, okay, so it could be there is one server wherein the path of each of these paths are specified, but that is never the case, right? What happens is, based on this path that you're typing, the load balancers that google.com has set up, it decides which server is your request supposed to route to. Okay, so that's what a load balancer is. That's what an application load balancer is. It basically helps you to route traffic based on the path that you will be typing over here. Okay, now what is something that we are going to accomplish today? What we'll do is we will have two EC2 instances, right? And these EC2 instances will have some website which will be hosted on it, sample website, and we will try to route traffic to each of these instances based on the path that we will be entering here. Okay, so let's try and do that. So let's see how we can accomplish this. So what I'll do is I'll basically first show you the setup, like how the EC2 instance has been set up. So this is my machine 1, right? So machine 1, if I go to the IP address of this machine 1, you can see that this is the default page that you see. This is the Apache 2 page will basically be present, right? But if I go to a certain path, let's say if I go to custom 1, this is a path that I've set up in this machine, then I will be routed to this particular page which says hello world. Accomplished. This is accomplished because in this particular server I have created a folder called custom 1, and when I route my in the path, when I mention custom 1, right, then I'm basically reaching this particular page, right? So similarly, if I talk about my second machine, this machine also on the default IP address, I will reach the Apache 2 page like this. But if I type in custom 2, which is basically again a folder that I have created in this server, I will reach this particular page which says hello world from machine 2, right? But the problem is that if I want to reach this particular page, I basically have to go to different IP addresses, and I don't want to do that. I want one particular point through which I should be able to reach both these pages. If I type in that particular IP address /custom1, I should reach this particular page. If I type /custom2, I should reach this particular page. But this should all happen from one single point of contact or from one URL. So in other words, what I mean is I should have one URL. This should be my main URL, just like google.com does, right? So I should have a main URL, and from this main URL, I should be able to access both these pages, that is machine 1 page and machine 2 page. And this is exactly how google.com is also working, right? So if I type in Gmail, it takes me to Gmail. If I type in Gmail over here, it will take me to Gmail. If I type in Drive, it will take me to Drive. So I don't have to log into two different URLs. There is one URL where I mention the path and they basically route my request accordingly. So that is exactly what I am also going to do, right? So for that, what I need to do is I need to create an application load balancer. So let's see how we can do that. So first of all, you need to come to your EC2 dashboard. It will look something like this. And what I'll have to do is I'll basically have to go down and I will have to go to load balancers. Okay. Now there are two concepts over here that you need to understand. The first concept is that you need to have a target group. What is a target group? A target group is basically a group of instances which are similar in nature. What that means is a machine one page.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Machines in one target group, right? Why? Because if I am going to google.com/gmail, obviously a lot of people are like trying to go to /gmail, and hence only one server will not serve the request. So what I can do is I can increase the number of servers, and what my application load balancer is going to do is it's basically going to route the traffic equally among all the target group, among all the instances which are there in that particular target group. So what that means is if a request comes in and if I type in that I have to go to Gmail, let's say this is the group of Gmail servers. Okay. So what it will do is if I type in Gmail, it will route my request to Gmail group, and basically it will route the request equally among all the Gmail servers which are present over here. Okay, understood? Similarly, let's say if this is the Google Drive group of servers, so if I type in Drive, it will route my request to this group, and then it will route the traffic equally among all the servers in this particular group. Understood? So this is exactly what we are trying to replicate over here. So first, let's create a target group. So let's create a target group, and this would be a target group of instances of EC2 instances. Let's call this target group as machine one group. Okay, here my machine one web pages instances will exist. Now in this, you have to select the VPC containing the instances that you want to choose. So we are in the default VPC, so we'll select that. This can be left default, like which HTTP version are you using, right? Health check. So the health check will happen on the index page, right? What is the index page? Index page is the page which is without any path. So without any path, you saw that the Apache 2 page was coming. If it is coming, you can set the health check for this particular, particular group as root. Or what you can also do is you can mention the specific path, which in our case is custom one. It's up to you. I'm keeping it root. I'm keeping the document as root. You can do whatever you want. Okay. So this will be the health check part. Then advanced health check settings. If you want to, you can edit this. But since you are understanding it today, let's keep them at default. If you read these are very self-explanatory. You will be able to understand it. And let's now click on next. So now that we click on next, now that I have got the machines that are there in that VPC, and now I have to select which machine I want to route my traffic to for this particular target group. So since this is the machine one target group, I will be selecting machine one like this. And this would be the ports for the selected instances. So Apache, since this is a web servers always work on port 80. So it will always be port 80 as mentioned over here, right? So now this is the machine that I want to add, and when you click on include as pending below, this particular machine one has now been added in the targets of the group. Okay, so it is pending as of now. Why? Because the health checks will run, and once the health checks are complete, once the health checks are correct, it will show that the target is approved. Okay, so we'll click on create target now. And you can see the machine one target group has been created, which is great. Okay. So right now you can see there is no load balancer assigned to it, which is fine. Right now, what we can do is we can check out the status of this particular machine by clicking on this target group, and we can then check if the machine is healthy or not. Okay, so we can just go to targets. So the status is unused. So why it is unused? Because it is not configured. So if we check quickly, it is not configured with any load balancer. That's why this status is unused. Okay, so we'll put it in the used category in a while. Meanwhile, we can create one more target group. Let's call this target group as machine 2. Okay, let's call this as machine 2. The VPC will be the default VPC. Everything would be the same. We'll click on next. And in this case, we will select machine 2 and we'll include it as pending below in the targets, and we'll click on create target. Okay, so both the target groups have been created. Now, obviously, you could add multiple machines in machine 1. That would mean that all your servers are basically hosting the machine 1 web page. Or in other words, with the example that we understood, that all your machines are hosting either the Gmail page or the Drive page, right? Okay, so you can include multiple servers, but for the sake of this demo, I'm just including one. So both the target groups are now created. Let's go to load balancers. Let's click on create load balancer, and let's click on application load balancer. So what will be the name of this load balancer that you want to give? Let's name it as application load balancer -demo. Okay, this will be an internet facing load balancer. Listener would be port 80 because this is the port that all the websites are hosted on. It will be a part of the default security group, and let's include it in all the availability zones. Okay. Do we want to enable global accelerator? I think this is a topic for some other session. So we'll leave everything default and we'll click on next. Your load balancer is not using any secure listener. That's fine because we are making use of HTTP and we are not making use of HTTPS, and that's why you're getting this warning. If you use HTTPS protocol, then you will need SSL certificate, which is supposed to be bought. But for this demo, we are going to skip that. Let's click on security groups, and we are going to make this particular load balancer a part of the default security group where all the security is open. Okay. Now let's configure the routing. So target group, let's select one. So we will select an existing target group. Okay, this refresh. Let me just configure this again. So this will be ALB-demo. It will be a part of all the availability zones. And we'll click on next. Load balance security, it will be the same. We will select the default security group. This is fine. And now in target groups, we will basically select the existing target group. And which target group that we do we want to configure first? Let's configure machine 1 target group. Okay. Now in this machine 1 target group, the health check is going to be this. This is fine. There's no need to change this. Right, and let's click on next. So in this target group, you have one instance and that is configured. That is all cool. Let's review it. Okay, this looks good. Let's click on create. So you will notice that I have not added all the target groups. That is all fine. Once this load balancer is created, we will start editing it. Okay, so you can see the state is provisioning. So let it do that. It will take some time to get deployed. Meanwhile, let me show you all the properties that you can configure. Okay, so this is an application load balancer that we have created, right? This is the DNS name. This is the URL that we will be using in order to connect to our instances. This is an internet-facing load balancer, which is fine. It is available in these availability zones. And this is a security group, which it will be a part of. And these are all the settings in the description. Talking about listeners, we will basically be using port 80 as a listener, which is fine. Talking about monitoring, so these are the things that are configured, and these are the requests. So all the requests can be monitored over here, right? When we talk about integrated services, we have not integrated any service, but if you do, you will find the settings over here. And these would be the tags if you add any, right? So let's wait for this to get configured. And then we'll move forward. Talking about the target groups, these are the target groups, right? So here you can see it is associated to ALB-demo, and we can just associate machine 2 now. Okay, so let's try going to listeners, and we will view or edit rules over here. And let's add a rule. Add condition for path, that if the path is /custom1, then we basically have to forward the request to machine 1 target group. Okay, I think this would be the correct one. And if we add one more, so let's save this, right? And let's add one more path or one more rule.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 is which type of storage service? A. Object. B. Simple. C. Secure. D. Block. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So it says if the path is /custom1, then we have to forward the request to machine 1. This is the first rule that we are adding. This is good. So this rule has been added. Now let's add one more rule, which says if the path is /custom2, right, then we have to forward the request to machine 2 target group. Okay, let's set this up. Let's save it. And this new rule also has been created. So now if we go back to our load balancer, I think now it should work as we intended to. So we'll go to target groups, and in target groups for machine 2, as you can see earlier it was saying unused, now it is showing ALB demo. If we talk about load balancers, let's see if it's active or it's in the provisioning stage. So it is active. If we check the monitoring, so everything looks good over here. Requests have started. There are no errors, which is now let's try going to the DNS of our load balancer, and let's go to custom 1. Okay, great. So if you're going to custom 1, well, we can see it says hello world from machine 1. And if we go to custom 2, so it says requested URL was not found. We'll have to remove this / from the end. Okay, so what we can do is, I think I missed out on one thing, and that one thing is going again back to the listeners. There's something called as a wildcard that you'll have to enter. Okay, so let's edit this rule. So if the path is custom2/star, then it has to forward to machine2. And similarly, if let me just update this rule first. And similarly, if the path is /custom1/star, then it has to basically forward the request to machine1. Okay, let's save it. Update this rule as well. Looks good. And now what I can do is come back to my load balancer. So if I'm going to the root, this is how it looks. If I go to /custom1, I'm getting hello world from machine1. And if I go to /custom2, it says hello world from machine2. So now what is happening is my load balancer is basically routing my request. This is my machine1 target group, and this is my machine2 target group. So if I'm typing custom1, it is routing my request to machine1. If I'm typing custom2, it is routing my request to machine2 target group, right? So this is working perfectly fine. Now let's change something. Let's change if we can. If let's say I go to, let's try to add one more rule. And here, let me show you what is the meaning of star. Okay, so star basically means that if it is custom2, it basically has to go to this. Anything after custom2 path, this star basically means anything after this custom2 path, it basically has to route to machine2 target group only. Now, what happens if I don't put this star? Okay, so I'll just go to my terminal very quickly. So this is my machine2, and here in the custom2 folder, what I'll do is I'll create one more folder called hello. Let me go inside the hello folder. Let me go ahead and edit an index.html file which says this is hello folder from machine2. And let me put the body tag as well. Let's save it, right? And then what we now will do is we will basically go ahead and this we first let me show you like what happens when the custom2 rule is there. So when I go to hello path, you can see that it says this is hello folder from machine2, correct? Why? Because we have typed in the path as custom2, and after that I'm going inside the hello folder. Works correct? Now let me show you something. So if I go ahead and if I edit this rule and if I remove this star, let's see what happens. So I've removed the star now. So only when the path is custom2, it is basically going to machine2. But what happens when the star is not there? Let's go ahead and identify. So if I go back to my machine, if I type in my load balancer, if I type in custom2, it is going to hello world from machine2. If I type in hello over here, can you see it says it's not found? The requested URL was not found on this server. So can you all think why this is happening? This is happening because now this particular load balancer is routing my request to machine1 target group. Now, why is that happening? Let's come back over here in the rules. So it says requests otherwise not routed should go to machine 1. So in case the rules are not being satisfied over here, the request will go to machine 1 target group. Okay. And why is the rule not matching over here? Because this star basically means whenever you add a star over here, it basically means that after this path, there can be anything. Whatever is the case, you have to forward it to the target group mentioned over here. Okay, so since I remove the star over here, now the rule is that if it's custom 2, it has go to machine 2. But if it's anything other than custom 2, it has to go to machine 1 according to this rule. So it's custom 2 slash hello, that is also violating this rule, and that's why this rule is being followed. So if I again edit this, if I just add the star over here, which is how the rule will work, let me update it. So now the star has been added. So if I go back to my load balancer, it was showing 404. All I'll do is I'll just do a refresh. So it will take some time for the rule to be updated. Now can you see it says this is hello folder from machine 2. Why? Because we have added this star over here. So guys, this was a quick crash course.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.